Hi, year 10. This is the second part of the video, all about pressure in liquids. And what we've done in the previous video is we've calculated the pressure in a column of liquid at different depths. We state why the pressure increases with depth. If you remember correctly, we had the equation of the pressure equals H, which is the height, multiplied by gravity, multiplied by the density, which is rho. Therefore, basically, if you've got more liquid above you, you've got greater weight. Therefore, the pressure is going to increase because pressure is force divided by area. What I'm going to do now is I'm going to basically go through, investigate what factors affect the upthrust of an object, and describe what factors influence floating and sinking. So now, if we were in a lab, we would do this practical. Sadly, we're not. Hey ho, the way it is. Now, as I'm drawing this beautiful diagram, I make a special mention to Harry Coop because he's one of the first people that actually liked my videos. Thank you, Harry. And I said to give you a mention. So what we'll do is we've got a beaker, we've got a beaker of water. Yep, it's one of Miss Mumford's famous experiments. And you then got a load of 100-gram slotted masses like this. Fantastic. Does it look like 100-gram slotted masses? Yeah, it does, near enough. Anyway, what you do is you take these and you would bung them into the water. And what you do then, at the same time, you attach your Newton meter on top, just like the diagram here. And you record the reading on this Newton balance or a force meter. And you would then also record the depth of the liquid, sorry, the depth of the masses in the liquid, and that would be height D. And then simply you record a table where you'd have, first of all, the depth D in centimeters. Gosh, terrible. Depth D in centimeters going through here, and then you record the Newton meter reading, which can be force in newtons. It's a bit better, isn't it? I'll try and tidy it up a little bit. That was a mess. Here we go. D is going to be in centimeters. And then what you do is plot a graph of these results. Now, because we are stuck at home, we haven't got a data available. Guess what? On page 138 in your textbook, there is a set of results. I know, aren't you excited by that? Okay, and I'd like to go through question 33 on page 138. And what you can do then is you can plot a graph. Yes, I know we're struggling with graph paper. You can do it on paper in your book. Doesn't make any difference. And what I'd like you to do is I would like you to plot a graph where you're going to have your force in newtons is going to be on the y-axis, and then your D in centimeters is going to be on, oh, I can't do this today. Try it again. Your D in centimeters is going to be on the x-axis, just like that. Okay. Now, if you do plots, they should look something like this, I hope, and you can do a line of best fit, which goes through like that. Okay, but the important thing I want you to realize with this, as the depth increases, the force or the weight of this object goes down. Why does that happen? Well, it happens due to this wonderful simulation, which I'm going to show you here, if I can get onto it. It says moving around. It's going to let me get onto it. It's not going to let me get onto it. Great when things do. Let me get onto it. Try again. Here we go. So, what you've got here is you've got two blocks, a block of wood and a block of brick. Now, if you look very carefully, they got the same volume. But if I take this onto the scales, it has a weight of 19.6 newtons. And because the brick has got higher density, it's got a weight of 98.00 newtons. Remember, density is how heavy it is for its size. Now, we all know this. If you take wood and drop it into water, bingo, it's going to float. Now, the reason why it floats is, yes, you've got the weight acting down at 19.6, but the water creates something called an upthrust acting upwards, which is that purple color here, which is also 19.60. Therefore, because the upwards force, the upthrust is equal to the weight, we have balance forces and it floats. But if I now take the weight, well, the brick rather, and drop it, it sinks. Now, if you look very carefully now, can you see, yes, it's got a weight of 98.0 newtons, but the upthrust is only 49 newtons. it is unbalanced. Therefore, this downwards force, the weight is greater than the upthrust. Therefore, it will sink. And going back to that wood, if you notice, is what happens when you put the wood in, it tries to displace water around the sides. Now, a very nice man called Archimedes realized the volume of the water displaced is equal to, well, the weight of it is equal to the upthrust. Therefore, it displaces water, and that displacement water creates an upthrust, which makes this float. Now, it only needs about that much displaced here to create the 19.6 to make it float. This one, well, as it goes deeper and deeper, it creates more and more an upthrust because the upthrust increases, but it can't ever reach 98 newtons, therefore it just sinks. And getting back to where I had my wonderful simulation here, diagram even, is you can see here the force against distance. It goes, as the depth goes down, this force decreases. And the reason why is because we've got two forces acting. We've got the weight acting downwards, but then, and I call this UT, is going to be upthrust acting up. As it gets further and further down, this upthrust is going to increase. So therefore, we looked at before, the resultant force, which is a combination of that one and that one, is going to get less and less. Hence, that is what you're recording on the Newton meter. The Newton meter is recording the resultant force acting down. Now, what you've got in your book, you've got these diagrams where here you have got U is equal to W, therefore it's going to float. Here you've got U equals W is going to float. But now on this one, now you can see the weight is going to be greater than the upthrust. Therefore, this one is going to sink. Okay, therefore this one has a greater density because it's heavier for its size, all the same volume, but that's got the greater density compared to that one, to that one. So that one's got the least, and then this is going to be the second, and that's going to have the most density. Okay, now with that there is I want to leave you with is I would like you to investigate something really fascinating called the bends. It's all to do with diving. Now, I've got my own personal experience about this in diving, but I'd like you to watch this YouTube video I'm going to put on, and it's YouTube videos all about a diving accident and how they save the person from the bends. So look up the bends, research it, find out what the heck it is and what it's all about. It's all about liquid pressure, but also, it's interesting, the person is saved by using a helicopter, but a helicopter flies very low. Why? It takes them to the hospital. Anyway, that's it for me, and that's all about, and I hope you now understand what describe what factors influence floating and sinking. Bye for now.